Okay, so let's go ahead and get started. First off, congratulations and thank you for showing up at the last session of Build. I know it's sunny outside. There's a weekend that we're running up against, and people are probably anxious to get to the airport and whatnot. I really appreciate everybody showing up here. We're going to talk about how we can make our apps smarter with Azure HDInsight. My name's Matt Winkler. I'm a program manager on the HDInsight team, and I spend a fair amount of my time figuring out how we put Hadoop into Azure, and then what our developer story is on top of that. And that's what we'll spend some time talking about today. We'll chat a little bit about what is HDInsight, then we'll dive into programming Hadoop, and then we'll talk about integrating Hadoop and HDInsight with your applications. Quick show of hands just to kind of level check with the audience. Anybody using HDInsight today? Couple, thank you very much. Folks building apps in Azure? Okay, a couple more. Thank you very much for that. How many folks are familiar with Hadoop? Okay. How many folks are using Hadoop? Okay. It's the smallest of the sets. Okay. Good data. So what I'm going to start off with is what is Azure HDInsight? And quite simply, it's the ability to create on-demand Hadoop clusters in Azure. We want to do three things, and we want to try and do those really well. The first is about elasticity. We want to make it so that you can very easily spin up as big of a cluster as you need when you need it. We want to make that super, super simple. We want to be able to make that so that anybody who's a developer in Azure can incorporate big data processing into their app really, really easily. And we also want to make it so that you don't have to become a Hadoop rocket scientist in order to be productive in that space. So there was a large set of folks that raised their hand familiar with Hadoop. A number of folks said they're using it. How many folks have just tried to get up and running with Hadoop? Of the folks who've looked into it. OK, a few more. The other thing that we want to do is make sure that it's secure. So right now, if you look at kind of what state of the art is in the Hadoop ecosystem, it relies a lot on network isolation. It relies on the fact that I trust the people who are going to use my cluster. And we want to make sure that when you spin up Hadoop clusters in the cloud, that they are secure by default, that they're isolated, and that you're in control of the data that goes in and who gets access to that. Another way you can think about what we're doing is we are the ability to bring big data processing on top of Azure storage. So we're doing two things, really. We're spinning up Hadoop clusters. And the second thing is that we're binding those Hadoop clusters to Azure storage. And what this means is that we decouple compute and storage, and this gives you a bunch of flexibility. You can keep throwing data into Azure storage, and then when you need it, you can spin up compute capacity, run your jobs, and then tear those down. If we think about the number of nodes that would be required to hold a petabyte of data, that's a fair number of nodes. And to keep those running 24 hours a day, 7 days a week, we can get the spreadsheet out and do some math there, but I can guarantee that that number of nodes is going to be substantially more expensive than putting a petabyte of data into Azure Blob Storage. So we'll go right into a demo. What we've got here is the Azure portal. So this is, if you've got an Azure account, walk up to the portal. Now, I've already registered for HDInsight. And so when I go into the taskbar here, it's under data services. And so we've got the ability to create databases and whatnot. What I'd like to be able to do is create an HDInsight cluster. Now, for folks who haven't registered for the preview, if you go in, you'll see this, and then it'll say, hey, click here. You click there. You basically say that you will not attempt to run a nuclear power plant on this, and that you're aware that it's a preview, and that you're cool with that. You say yes to that. That drops you into a queue, and then we're onboarding folks pretty regularly. The wait time for the queue is under a week right now, just to kind of set expectations for folks who go out and do that. And we really ask you for just a couple of pieces of information. The first is, what the heck do I want to call this thing? The next one is, how big is it? Then a password for the user on the machines. And then which storage account that I want to bind this to. And this is the first thing that I want to talk about. When you create an HDInsight cluster, we want that bound to a storage account. And that's going to determine which Azure region we're going to spin the cluster up in. So rather than saying up front, I need to be in East US, it is, I want to have HDInsight compute on top of an Azure storage account that is sitting in US East. And so what you can see here is these are all of my storage accounts here, and some of these are highlighted because we're only in a couple of data centers right now. Then I say go here, and this will get me off to the races. Our average time to create a cluster is about 10 to 15 minutes. The interesting thing is what we've seen is that's relatively invariant to size of cluster. So if you want to spin up a 4-node cluster or a 30-node cluster, it's going to be about the same time. A couple of folks may have seen when I showed this drop-down that we go up to 32 nodes. Right now in preview, we are capping preview customers at 40-node clusters. If you would like a larger cluster, please come talk to us. We are more than happy to give you larger clusters. If you spin these up, though, you're running a fair number of machines at a given time. And so we want to make sure that you know what you're up to before you go and spin up 400 nodes. You can do that. We'll let you. But that can be a check at the end of the month, or a bill at the end of the month that might be a little painful to write a check for. So that'll go ahead and create my cluster. The other thing that I want to show here is, so this is the portal experience within the Azure Management Portal, but we're also delivering into the command line tools. And so I have both the PowerShell and cross-platform command line tools in order to do cluster creation, cluster management. And so I'll show these here. And so for folks that aren't familiar, this is the cross-platform command line tools. These will run on Windows or Linux or Mac machines, so you can manage your cluster without running on a Windows machine. And we expose a couple of sets of operations here. So the first is, let me list my clusters. This will go out, this authenticates and says, hey, tell me all my clusters. It'll list the two of them. We can dive in and see what's going on with the mwinkle build cluster. And you'll see here, this will tell me, hey, this is an 8-node cluster. That's the URL that I'd use to connect to it. How long has it been running for? And there are a few other operations I can do here. I can go ahead and drop clusters as well. I'm going to need them for the demo, so I'm not going to drop those. The other thing that I want to show about the command line tools is within the Azure portal, we surface the simple set of options. There's the very simple set of options that are here inside of Quick Create. There's a larger set of options that are surfaced via Custom Create, where I could pick 6 nodes if I wanted to rather than 4 or 8. I can configure the username and password. I can also configure storage accounts. I could provide storage accounts from other Azure subscriptions. There's a number of other cluster configuration options that we surface that we don't expose via the UI. And we'll use the command line tools in order to do that. And so an example of this is I want to be able to actually do 2 things here. I want to be able to add multiple storage accounts. So when we go through the portal, by default, we bind to a single storage account. If I want to be able to scale out across storage accounts, either because I have that much data, or I want to take into account what the throttles are at the storage account layer, I can go ahead and do that. Or if you can imagine, I've partitioned out my accounts in such a way that my web apps are writing to one and my clusters are up against another, but occasionally I need to read from that first one. So you can add multiple storage accounts here. I imagine we have some limit on this, but it's within the realm of reasonable. So if you need to add 10, 50 storage accounts, you can go ahead and do that. The next thing that we surface here is the ability to provide a metadata store. So the metadata store for an HDInsight cluster keeps track of a couple of things. It keeps track of the Uzi workflows that are running, and then the collection of metadata that's stored in something called hcatalog. And you can think about hcatalog as the definition of all of my tables and schema that I want to be able to write queries against. And so if you want to get to this pattern of spin up a cluster, do some work, and tear it down, what you want to be able to do is have that metadata about which set of tables live beyond the lifetime of an individual cluster. And so what you can do here is you can provide, you're essentially providing a connection string to a Azure SQL database. And that'll allow you to reuse that metadata store across multiple lifetimes of the cluster. So now that I've got a cluster up and running, let's go back here. And we'll pick the mwinkle build cluster. Now I can move into using the cluster. And what we see here is really the management of my cluster. I can see a little bit of what the tasks are that have run on it. I can dive into some monitoring metrics. One thing, I'll make just a completely honest statement here. This is pretty sparse right now in terms of the monitoring and metrics that we surface here. That's something we're adding over time as we move forward with the preview. So what you see here today will not be the same set of data that is here in 2 to 3 to 4-ish weeks when we'll do the next update of this, and we'll land a couple of more pieces of information here. But you can see here I ran a pretty big job that used this about 30 map tasks. I can also drop my cluster. The other thing I can do here is I can connect to my cluster. So a lot of times, for folks who have played with Hadoop, the primary way you usually interact with it is via the command line. And so if you want to RDP into the head node and play around on the head node and issue your Hadoop commands, you can go ahead and do that. And the way we do that is just connecting here, and that's the same experience that you have when you connect to any Azure cloud service. We also have a management dashboard. We'll open this up real quick. And this is really useful when you're just getting started in order to be able to get the cluster to do something. So oftentimes we talk to customers who say, hey, I spun up an HDInsight cluster. What do I do with it? How do I make it do something? And so the dashboard here allows you to do that. Over time, you'll see the capabilities that are here move into the Azure portal. Because if you look at this, you might say, gosh, this looks a little different than the Azure portal, and we will fix that. But here, for instance, if I wanted to run a sample on the cluster, I can say, hey, I'd like to run a 10 gigabyte gray sort, which is a version of a common benchmark that we use called TerraSort. If I want to estimate pi, so a couple of the most basic things people usually do with Hadoop clusters is either count words or calculate pi. So we've got those samples here, so if you want to use 40 nodes to calculate pi to a ridiculous amount of precision, feel free. So that's the dashboard. And let's switch back to the deck. And so at the core of HDInsight is Apache Hadoop. And if you look at Hadoop, Hadoop essentially evolved out of a number of the web companies that were solving basically the same problem. If you rewind the clock about 10 to 12 years ago, you had companies like Google, like Yahoo, like Microsoft, that were trying to solve this problem of, hey, I'd like to have a copy of the internet under my desk, and I'd like to be able to ask questions about it. And that induces two interesting problems. One is, how do I actually store a copy of the internet in a reasonable and cost-effective way? And the second thing is, how do I express some set of queries on top of that? I want to be able to power my search engine, basically. And so Hadoop in particular was interesting because there were two research papers that were published by Google, which have now kind of become kind of classics in the distributed system space, which were the MapReduce paper and the Google file system paper. And Hadoop started as an open source implementation of those papers. And today, Hadoop is being used at a ton of these web companies to solve some pretty massive problems. The largest one that I know of is at Yahoo. They're running about a 4,000 node cluster. That's the last time they talked about it. I think they're running a much bigger one. That's thousands of nodes, multiple petabytes of storage. Facebook has tons of these as well. But the interesting thing is that it's not just the domain of people who have these ridiculously large data sets. The nice thing about Hadoop is that it gives me a way to compute on data without knowing what questions I want to ask when I collect the data. And that's a pretty interesting thing. So let me talk about the pieces and parts of Hadoop. So Hadoop starts out with MapReduce. MapReduce is the assembly language of Hadoop. It's the lowest level programming model. If you're a functional programming junkie, this makes perfect sense to you. It's easy to do some things with it. It's really hard to do other things with it. And so very quickly, what was recognized within Yahoo and Facebook and other places was that the universe of folks who can effectively and efficiently write MapReduce is pretty small. And in order to do a lot of common analytics tasks, it's pretty hard. And so enter what we always do, which is let's add some more abstractions. And so this is where something like Hive came along. Hive is a SQL syntax that compiles to MapReduce. So anybody in here who can write a select statement can go ahead and, by the end, 5 minutes later, can be writing a Hive query. Cool thing about that is that compiles to MapReduce and then distributes out across your 4,000 nodes. Pig came up because not every problem makes sense as a select statement on a rectangle. That's great for SQL stuff. Pig, imagine you've got a lot of unstructured text, you've got an index of the internet, and you want to be able to reason over these HTML blobs. How do you go do that? Pig's a data flow language in order to program Hadoop. As I move along, I need to commonly interact with relational stores. And so I either want to get data out, or I want to, at the end of my Hadoop computing, I want to get data into a relational store, because that's where I've got my reporting engine, that's where I've got my analytics tools. Scoop is a project for that. Pegasus is a library around graph processing that allows you to have a programming model for processing graphs that, again, compiles to MapReduce. Cascading is one of my favorites. This is a really nice Java API. So for the .NET folks in the room that are familiar with LINQ, there are a lot of linkisms that are present in cascading in order to give you a nice kind of fluent query building experience that, again, compiles to MapReduce. Now, the interesting thing, for Pig, Hive, and Cascading, I've said you can write a query and it compiles to MapReduce. The other nice thing about this is, like any other part of the universe where we have a query that we compile, we can start putting smarts into the compiler. And what will happen as these things evolve is that the output from the compiler will be much better 99.9995% of the time than what we could handcraft in MapReduce. So not only do you get a productivity boost in terms of it's easier to write queries this way, you also get the fact that it's most likely going to be a fairly performant implementation. So Storm is an interesting project from Twitter. That's a complex event processing system that's been ported to sit on top of Hadoop 2. Uzi is a workflow engine, because oftentimes you want to start laying these things together. Drill is an Apache project that gives you real-time query that's similar in a way to Storm. Scalding is a Scala DSL on top of Cascading. I think you're starting to get the point. These things all have relatively funny names, and there's a vast ecosystem of these things. And they are different things you can kind of pick up off the shelf and use to accelerate your time to getting something done with Hadoop. If we were living in the age where everybody still had to go write MapReduce jobs for this, Hadoop would not nearly be as pervasive as it is today. But the thing to remember here is, and I'll get to this later, is I'm not going to stand up here and say that any one of these is the best, because quite frankly, none of them are. They all work well for different types of problems. And so you'll have to combine them typically as you want to move forward. Now, the other thing that comes up when I kind of talk about this, because I kind of set up this, hey, Google needed a copy of the internet, and Facebook uses thousands of nodes, people are usually kind of reply to me and say, hey, I don't have that problem. Even in my wildest dreams of crazy success, I will never have that problem. And what I would say back to that is, I think as you build apps in the cloud, there's an opportunity for us to do something different than we did on-prem. And that is, the cost of storage is getting driven so low that it is becoming increasingly easy and affordable for me to collect data, even though I'm not sure exactly what I'm going to do with it. If we think about kind of our common model of guy walks up and wants to build an app, he gets a database, he thinks very hard about what's going to go in the database. He has to be very intentional about everything that he's going to write to the database and the format. And I don't have a lot of room for unstructured data, or data that I'm not exactly sure what I'm going to go process. And so the question that I would pose back to you is, in the apps that you're building, what is the data that you're not collecting? And why aren't you doing that? So if you're building a mobile application, imagine the telemetry data that you've got. You're probably not collecting what are the coordinates of every click, right? Could I do something interesting with that? Yes, I could do some very interesting analysis of how are folks going through my app. What are the points in my app where there are transactions that I care about? Read, I make money on these. And where are they falling out? Right? This would give me a way to collect data very cheaply to eventually ask those types of questions. The pattern that we see, so we'll switch now and talk about kind of the patterns of big data computing, typically follows these 4 steps. And the first is the acquire phase. This is about how do I land data in a place that I can eventually ask a question of it. The compute phase, which is where I'm asking a question or a series of questions about my data. That's going to generate some amount of output. I need to decide what to do with that. And so I'm going to publish that somewhere. That could be right back into Azure Storage. We could do some other things with it. And then the last part of this cycle is to consume that. And we can talk about a number of different ways that folks can consume this. But ultimately, what we get is a very nice virtuous cycle through this. And the way I like to talk about this is, let's start with an app-centric view of this. I've got apps, I've got game consoles, I've got devices, I've got check-in information, I've got geolocation information about my delivery trucks that are out there, data on my shopping cart. What we need to be able to do is land all of that data somehow into Azure Blob Storage. What I can then do as my data lands in Blob Storage is I can spin up HDInsight clusters in order to compute on top of that. And compute really falls into 3-ish phases. The first is experiment. This is I think the data can tell me something. I don't really know what it is. Let me try and figure out what question I want to ask. And there's a pattern of ways that we go through that. There's typically a pattern of shaping the data, which is when I land the data, the best thing to do there is keep it in its raw form. Right? And that can be text files from logs. That can be, in the case of devices, this could be just the binary serialization from the device that eventually, if I need it, I can go ahead and decode it. But oftentimes, I'm not going to always want to operate on that raw form. I'm going to want to start to shape that, particularly if we think about the traditional analytics space, where eventually we've got a bunch of end users that know how to think about rectangles. We need to get data into those rectangles. And then we can query against that. And I'm using query as a very broad term here to describe long-running computation on top of a bunch of data. So it's not just select star from. This is also a graph algorithm, or it's a machine learning algorithm. That's all going to be done. Now I need to dump this data out. And I can go ahead and dump it into a tabular form. I can dump that into a relational store. If I've got a document database, I can go ahead and land it there. I could produce files out of this, land those somewhere. And all of these are going to be different paths that I'm going to use in order to publish the data. Now, where this starts to get interesting is I want to be able to consume this. And so consumption falls into 2 things. The first is, and normally when we talk about Hadoop, you think about BI and you think about data analytics, where you have a data scientist or an analyst who is the consumer of the data. And that is definitely one very interesting segment, which is the set of folks who have the right knowledge about the business and about statistics to be able to say, what questions do I want to ask? And ask some questions and get some insight and create the reports that are hopefully going to help shape the application. Now, the more interesting part of this, we've kind of, we've got a long history of talking about what the analyst does and BI tools. And I'm not going to show BI tools here or reporting services or anything like that, but you can land it there. The more interesting thing, and if we think about the maturity model or the progressions that someone goes on this journey, typically we start there, where somebody's asking a very basic question, getting it in Excel, playing around with it. But where the power starts to come in is, how do I feed the output of that processing back into my application? And the example that I'll use as we walk through the talk is that of a recommendation engine, which is, imagine I'm collecting all of the data that my users are, all the activity that my users are doing on the site. And I want to be able to create recommendations for them. Right? I want to be able to say, hey, if you bought item X, I think you're interested in these 3. Or people who read this book are interested in also rated these 4 books highly. Well, I can go land that back into my app. Right? I want to land that into whatever online store, whatever document database or relational database is being used to power that. And then this cycle just starts to repeat. And as we start to see organizations get more mature in this, the types of questions that they start asking just get more and more sophisticated. Because the first set of questions then become the baseline. At first, everybody's super impressed. Oh my gosh, we never knew that people who bought X also buy Y. Great insight. OK, that's what you did yesterday. What's going to happen next? Right? And so this starts a really nice cycle of moving through this and just getting better and better and making your app more efficient. And efficiency here I'm using very, very broadly, whether that's extracting more money from customers, whether that's operating more efficiently, tweaking machine configurations. And this is a pattern. As organizations start to embrace data and what they can do with it, we're really seeing this cycle start to emerge. So let's talk a little bit about the developer side of the house. We're going to get into some code here very shortly. And I want to just kind of talk about how to think about developing for Hadoop. And really, we divide this into 4 layers that we split in 2 different scenarios. The first is authoring queries. Right? This is how do I go and ask the system a question? The second half is integrating that into your application. Oftentimes, when you look at a lot of the buzz that's happening around Hadoop, it's on that left side, which is how do I author a query? Hey, there's a new way. There's all of those crazy named projects that I showed earlier. Those are almost all about authoring jobs. We'll spend some time talking about integrating because I think that's the more important part. Most cloud developers aren't going to have just an HDInsight cluster. If you want to do that, that's great, but there's got to be something usually to put some data in and get some data out. And that integration piece is something that we're working very hard on so that you can add these capabilities to your app. You can start without it. You can eventually add it. But within the stack, we think of it at a number of layers. At the most basic, it's core Hadoop. So Hadoop is an Apache open source project. Microsoft is contributing code to the Apache project. We're participants in the ecosystem. We have committers to the Apache project on staff. And we're partnering with Hortonworks, which is one of the distribution vendors, as the distribution of Hadoop that we use. And there's a bunch of interesting things that we can do there. And the nice thing of playing around at that layer is that everything that we do there to make things better just pays dividends up the rest of the stack. So we're investing a lot in a project called Stinger, which is all about making Hive substantially faster. So the HDInsight team sits inside of the SQL Server team. There happen to be a set of folks there that have spent a few years taking queries that look like SQL and optimizing them. We've now got those folks working on Hive and contributing those patches to Apache. And that makes everything better. The next thing that we're doing is pushing for a consistent set of REST APIs. A lot of Hadoop right now is about Java RPC and wrappers around that. And so you get a bunch of mishmash of client versions have to match server versions and binary protocols and all that fun stuff that I thought we had lots of fun conversations about at PDCs gone by. And so we're working really hard to get a consistent set of REST APIs on top of this because we want that to be the programming interface that folks use. Because that allows us to pretty easily have a breadth of clients. We're obviously going to work on clients in .NET. We're also going to work in clients in JavaScript and Java as well. But because if we land in a place with the REST APIs, you can build your own too. So if we don't have a Ruby one, you want to build one, that's awesome. And then finally, there's a set of end user tooling. This is how do I help somebody who's a Visual Studio developer play with Hadoop. And so as I kind of walk through things, this is kind of the frame that we've used to think about how we're going to go invest here and build. And this slide then builds out and basically says a bunch of the stuff that I said before. So let's talk about acquiring the data. Really, this is about landing data into blob storage. A couple of different ways to do this. This is applications writing directly to blob storage. This is about consuming a set of data that's available via web services. It's also about pushing to blob. So this is from going from on-premises to blob storage. There's a bit of a physics problem here. Compute the aggregate bandwidth of a FedEx truck full of hard drives, and it's probably bigger than the pipe you have going out of your data center. But where this scenario is really interesting, one is when the data size matches physics. The other one is in a distributed sense, which is we've worked with some manufacturing companies that have installations around the world that have internet connectivity. And so any one of those installations isn't really producing big data. But then they have tens of thousands of these installations, which then, if all of those are writing to BlobStore, you've got a fair amount of data. And the other thing you can do is copy to blob. I'll show you kind of some fun utilities for that. So the first thing that I'll show here is just what this looks like. So this is Cloud Explorer. This is a tool for browsing blob store that happens to honor a naming convention which includes slashes. The file system that we've built does the exact same thing. And so what you see here is the file system view from the perspective of the mwinkle build Hadoop cluster. So I have an example directory, an HDFS directory, a user directory. If I dive into here, this is where I've got a number of the jobs that I've been running. And so anything that can write into BlobStore can land data in a way that I can consume it from HDInsight. And so let's look at some of the tools we've got for that. So I'll show PowerShell here. You can also programmatically do this via the API. There are client SDKs available for a number of programming languages, so don't feel constrained that if this is not PowerShell, I can't do it. That's just what I'm showing here. The first is that very basic, which is how do I upload from the local machine? And so there's set Azure Blob content. This is the very basic way to go ahead and write that data up. The more interesting one to me is this start Azure Storage Blob copy. And let me kind of walk through, let me motivate this a little bit. So I'm going to go to 3 interesting data sets. This is a book crossing data set. This is 1.1 million book reviews from 270,000 users on about 250,000 books. I've got a data set here which is basically the same set of data around movies. And if I look at these are all relatively small files. I don't think the biggest one is bigger than a few hundred megabytes because they're compressed. I can download those and I can upload those pretty easily myself. I can sit at my desk and do that. Let me show you a more interesting set of data. And this is where this officially becomes the weirdest build talk I think I've ever given, because I'm talking about a Java app and now I'm showing a Google API page. This is a set of n-grams from the Google corpus of all of the books that they've scanned. And n-grams are just tuples of word sets that identify how frequently they occur. And linguistic folks love to use these in order to figure out patterns and all sorts of interesting data. As you can see here, look, I'm not going to click every one of these and download it and then upload it. That's going to be a problem. It's going to particularly be a problem because just the 3 grams are about 1.5 terabytes. So that's a bunch of data. It's more than the hard drive that I've got in my laptop, and probably more than my IT guys want me to saturate over a wireless network twice. So what we can do is use Azure Storage Blob Copy. And what this guy does is this will point to a publicly accessible URI. And so in here, I'm just pointing to a single instance of one of those Google files. And then I'm going to specify a destination container and a destination blob. And here I'm providing that name. I want it to be from Google whack all_a.gz. And I have to do a little bit of work to set this up. But what this will do, this will set up a task that runs inside the Azure Data Center to go and reliably download this. I don't have to download that to my machine. So I can just say, hey, Azure Blob Store, I'm really interested in this URI. Go get this. Where that starts to get really interesting, and to help me with this problem, is I wrote a little thing where I extracted out all the URIs into a text file. There's about 760 of them. I just iterated over that set of URLs calling start Azure Blob Copy. What this did was spun up 760 tasks that needed to run. And over the course of the next day and a half, I ended up with my n-grams container. And you can see here's the WAC from Google. And it brought over all of these files for a total of 1.5 terabytes. And hey, ingress into an Azure data center is free. So we don't charge you to bring it in. We will charge you to store it. So I'll get a bill for this at the end of the month. But the cool thing about this is one of the advantages of us building on top of Azure Blob Store, right? There's a bunch of interesting capabilities that are going to get added at the storage layer. This is one of them. The fact it's geo-replicated is another. I don't have to go figure out how to geo-replicate Hadoop clusters. I just write it in Azure Blob Store, and it'll go ahead and write that to another data center in the same geopolitical governance region up to at least 400 miles away. That's kind of a nice capability for folks who are concerned about not ever having the remote possibility of losing the data. Now, the other thing that I want to point out here in the acquire phase is format. Here I'm just keeping this as the source format, which is just gzipped files. What we'll see as we move forward is that Hadoop has a bunch of support for various compression codecs. And so I don't have to run a task on this to undo all of these gzipped files. I can just leave them there and party on those later. So now let's talk a little bit about compute. This is the point I made earlier. There's no one tool to rule them all. Kind of three of the patterns that we see is really this notion of kind of pre-processing data, which is about cleansing or shaping data, or I've got another interesting data set that I want to do the join. And then really kind of traditional analytics. This is kind of the common BI story. How do I provide the aggregates? How do I go ahead and load into an analysis services data warehouse? The pattern that we like to talk about here is that of a digital refinery, which is I'm going from a really big source into a refined set of smaller data, where that data is manageable by the consumer. Or you can say going from really big data to just big data. If you would go from multiple terabytes into landing into a couple of gigabytes of a few million rows that you can go ahead and easily land into a relational store of your choice. And then the area where there's kind of a lot of excitement about this space is really in the advanced analytics, which is how can I start asking questions at a scale that I could not before? And that really falls into kind of that experimenting and then creating models, testing against models. This is why data science is a very lucrative position to be in if you've got the right background for it. Just head out just southeast of here, just say you're a data scientist, and somebody will buy you dinner tonight. I guarantee it. And the thing that we're doing here is we've got the SDK and command line tools for submitting and managing these, which means you can very easily go ahead and run these jobs, and that's what I'll show as we hop back to the demo. So this is going to be, I just want to set some context here. This is going to be a bit of a whirlwind overview of how you write Hadoop code. You could have multiple sessions on any one of these technologies. I just want to give folks a little bit of an idea of the flavor and what we're talking about here. So the first thing is word count in MapReduce. And again, what I would love to see is that no one in this room ever has to think about or write MapReduce. I very much believe that for the vast number of Hadoop users, MapReduce is an implementation detail. It's the assembly language. It's really good, particularly for all the folks that are here. You guys like knowing how things work. This is what it's all boiling down to, a map function and a reduce function. And this is the Java implementation of this. So it's kind of verbose. We've got a bunch of kind of ceremony that we've got to do here. We don't map the generics kind of all over the place, so you've got to redeclare types. So it's a little gnarly to use, but this is word count. Pretty much everybody who picks up the book with the elephant on it, this will be the first thing that you go ahead and do, because what else to do with a giant distributed compute system than shred strings and count how many words were in them? So what I can do here, if I were sitting on the cluster, what I would do is I would open up the command prompt and I'd run Hadoop jar, pass in the jar, pass in the class name, pass in a chunk of arguments into that. But if you haven't kind of picked up on it, we really would like people to not have to remote desktop in and open a command prompt. We'd really like folks to be able to just submit that job from their desktop using a tool that they are more comfortable with. So what I'll show here is the command line experience for this with the PowerShell scripts. This is built on top of a .NET SDK, and so you can easily incorporate this into your app if you want to be able to have, hey, let me have a user put in the set of parameters to kick off a job. You can go ahead and do that. But what we've got here is a set of HDInsight job submission types. So this is submit a Hive query, submit a MapReduce job, or submit a Pig job. The nice thing about this is if you have another tool, typically you can put that in through the MapReduce job. So when we talk about scalding or cascading, those can very easily be submitted because it just compiles to a jar that you pass to it, because it's just a bunch of sugar on top of that. As we expand HDInsight to include more interesting projects, this will certainly expand as well. So let's go ahead and do a MapReduce job. Let me zoom in on this. Sorry about the font size here. So here we've tried to boil it down to the minimal set of options required. So I have to specify which cluster. So m build. I have to specify the jar file. Important thing to note here right now, these don't upload the jar file. You have to have the jar file already uploaded. That's just an implementation detail that'll get fixed eventually. You specify the class name, specify the set of arguments, and then the status directory is just, hey, where do I want to go write these things out? Write out the updates as this job is executing. So I'm not going to try and write one of those from scratch. I'll show one that I've already built. Let me zoom out here. And so this is actually a job that's running. So let's see which jar file it is. Impatient22. You can tell I was preparing for a demo and had a fair number of iterations to get it right. I want to run the filter many recommendations Hadoop job that's contained within here. And then I'm going to pass it a set of arguments. And this gets basically job specific. So you know as the author of the job what arguments it expects. You would go ahead and pass these here. Let me, one of the arguments is input, obviously. Another is output. I'm going to change the output directory just so I don't overwrite what I want to show in a few minutes. Go ahead and kick that off. And what this will do is this will go ahead and return a job ID. And what I can do is turn around and ask the cluster, tell me all the jobs that are running on this cluster. This will go ahead and return 1 just because I bounced the server right before I started the demo. So we'll get Azure HDInsight job, mwinkle build, pass that in. And what you'll see here, this is going to return a bunch of status information. Again, this is on top of the SDK. So if you wanted to build your own app on top of this, rock on. If you've got folks who are familiar with PowerShell, they can use this. If you're working on a Mac or a Linux machine, you can use the cross-platform command line tools, and this stuff will be there as well. The other thing about the cross-plat tools, those are written in Node.js. So there is a Node SDK that sits underneath that. So if you're authoring Node apps and want to kick this stuff off, you can go ahead and do that too. And so that's how I would go ahead and submit a MapReduce job, run it. Eventually, we would see this guy finish, and I'd be able to get all the data out of here. So if we go here, let's go into my admin directory. You can see there's book production 11. This job is still running. We haven't really put any sugar on top of what's output here. You'll kind of look here and be like, oh my gosh, there's a file called standard out and standard error. That's just what Hadoop is putting out. We'll go ahead and add some sugar on top of this. So hopefully, in the most cases, you don't have to think about this. But this is what's sitting under the covers. And if we look here, that job is still running. If I look at the last time I ran this job, you'll see it outputs a whole bunch of files that I'll consume in just a bit. So that is MapReduce. And I hope that's, for most folks, the last time you kind of look at MapReduce. I hope you move on to bigger and better things. Let's look at some of those. So the first, this is Pig. I'm just going to show what Pig looks like. Pig is a data flow language. It doesn't have a good thing that I can compare it to. It's really, it's a unique animal. But what you can see here is you're essentially, the mental model for Pig is you're operating over a set of tuple streams, and you're putting a set of operations on those tuple streams as they go through. And so what you can see here is I'm operating off some set of Twitter data. It's comma separated. That's what using Pig storage with a comma is going to go ahead and do. Pig is super, super flexible for unstructured data. Or if you've got data that's got a bunch of errors and you want to do a bunch of kind of munging on the data, Pig is super, super useful for that. And then what you can see here is that we're just walking through and operating on these various tuple streams. And each one of these generates another tuple stream that I then pass down. What this forms when the compiler gets this, is a giant graph of things that compile to MapReduce. We can do some interesting things now. We can recognize where I might be using the same output in multiple places. And again, this will be substantially more efficient for me to write this than all of the MapReduce jobs. I would spend all day writing the MapReduce jobs to do this, that I can just kind of write in 22 lines or so of pig. And again, to submit that, I'm going to do basically the same thing. Now, Hive is where it gets interesting. If you look at this, you could easily, if you gave it a quick glance or it was a little late when you got back from the party last night, look at this and just think, hey, that's SQL. Let me hand it to Enterprise Manager, and I can go ahead and run this, and it'll be great. But this is Hive, and it's a SQL-like syntax for doing two things: data definition and data manipulation. And so what you're seeing here is I'm creating a table on top of that 1.5 terabyte store of 3 grams. And I know that that's a tab-delimited file. So first I know rows are delimited by lines. The fields are delimited by tabs. And I know that there are 4 fields. There's the 3 gram itself. And then there is how many times does it show up, what year was that, and then how many books did it actually show in. And the interesting thing that I'm doing here is I'm creating an external table. And what that means is that I don't have to load this data anywhere. I'm just saying to the metadata store, hey, there is a table named 3gram1. It looks like this. Whenever you want to run a query against it, go to that directory and just figure stuff out. Hive's very much a schema on read database. Traditional relational databases are schema on write. What that means is I can go ahead and create this on 1.5 terabytes of data, and it takes about a second and a half, because I really haven't done anything except add some metadata into the system. The cool thing that I can then do is I can turn around and say, over 1.5 terabytes of this stuff, let me do select star. And obviously, I'm going to put some amount of filtering on that, because I don't want to just generate another 1.5 terabytes. That's a great way to exercise the storage system, but they tend not to like us not doing productive things on it. All of the things that you expect about SQL are here. So the ability to do joins are here. The ability to do more complex predicates in terms of filters, group bys, aggregates. There's some interesting aggregates that are more big data specific in terms of statistical histogram computation. The other thing that's interesting about this is you can pretty easily build UDFs for this in Java. And so if you have some set of business logic, you can expose that as something. So you can do select, do my stuff from blah, blah, blah. That will get, because all this is a MapReduce task or a series of MapReduce tasks that can host the JVM. It's already hosting the JVM. That'll just pull in your UDF and execute it. So that's kind of cool. I can go ahead and run these as well. Now, the interesting thing here is with Pig and Hive, there's really 2 modes. There's kind of the I'm playing around mode, where I can write a query that sits on a single line. And then there is the I've got a bunch of stuff mode, in which case I'll have files. And so you can also just have HQL files, and you can submit those as well. Last thing that I want to show is something called scalding. So this is a Scala DSL on top of cascading. And for anybody who's friendly with Link, you can look at this, and this starts to look somewhat familiar. And this is kind of my preferred way to write more complex jobs right now, just because I only have to write about this much stuff, and it's going to do a fair amount of work for me. Here, what I'm doing on that book data set, I start off with, let's go look at my reference data. If I look at books, it actually is 3 different tables. It's a table of ratings, a table of books, and a table of users. What I really want to get to in order to feed into my recommendation engine is user, book, recommendation. Those are the 3 things that I'm most interested in. And so I'm going to do a little bit of pre-processing to land in a file that does that. And that's what I'm doing here. So I'm reading in, this is reading in the ratings, reading in the books, and then I'm joining those. Interesting thing about Pig, Hive, and cascading, they all make you think a little bit more about joins than you do in SQL. The query optimizers aren't really using statistics yet, so you have to specify, hey, I'm pretty sure the table on the right-hand side is smaller or bigger, or it's really tiny, and I know I can put it in memory on all the machines. And each of those will have a slightly different performance characteristic, so you have to think a little bit about that. But here I'm doing the join, and then I'm projecting out, hey, give me that user title and rating. Now what I'd like to do is, now I want to start getting a little fancy, and I want to actually do the similarities. And so what we're doing here is essentially correlation across two vectors. And there's a bunch of math here, so we'll skip that. But as you can see, there's, trying to see where this stops. There's about 170 lines of code here that will compute four different correlation metrics. So if you're statistically minded, there are different times you want to use different ways to compute correlations between these things. And the code to do this is pretty succinct. We're kind of staging, doing a number of the interesting columns that I'll use, and then as I want to onboard more of these correlation algorithms, I can pretty easily do this. You'll see these are two other columns, and they're a line or two of code, largely because we're pre-processing a bunch of this stuff. So I went ahead and ran that job. And what this ended up coming out with was a 32 gigabyte output file. This is that million ratings over 250,000 users, 250,000 books. That's a lot of rows. I can't really look at that in Excel. I can't play around with that. So the next thing that I wanted to do was say, hey, I'd really like to filter this down. And so the way I'm going to filter this, I'm going to go ahead and grab that. This is what it looks like. It's going to have two different fields around number of raters. I only want to look at items that have been rated by more than 100 people each. Right? I'm just trying to apply some amount of filter so that I don't have, look, there's one book that a guy rated once. I don't want that kind of factoring in and kind of creating some noise. When I run that, what this will output is all of these files here. And the total of these is pretty small. So we'll look at these real quick. It's about 53 megabytes. That ends up being a lot more manageable. And if we were to open these up, let's pick a small one. Open this in Notepad. What you'll see here is this is just a tab delimited file. Right? So that's super easy for me to consume downstream. We'll get to consumption in just a sec. Next is publishing. So you can publish back into Blob. That's what I've been showing now. Into a reporting engine or into an online store. So landing it into SQL or Mongo. Or pick whatever data storage technology you like to use. As long as it's running in Azure, that will all be quick and very, very fast. If you want to host it somewhere else, just, again, kind of remember physics. If you've got to move 1.5 terabytes, that's going to take a little bit of time. It'll take a lot more time going out of the data center than within the data center. The other thing that you can do is just add it as another table. So sometimes what Hadoop jobs are doing is getting things down to a smaller set of tables that fit more what my analysts know how to think about. So we use HDInsight to power a bunch of analytics we do on telemetry of our Azure SQL database service. And this is the pattern they have. There are a couple of queries that they've written that are super hard to consume, but they create a common set of data. Then they process those into 5 or 6 different tables that people can then use downstream. There's a tool here called Scoop. That's basically what you want to use if you want to go out from this and land it into a traditional relational store. Mongo has something, Cassandra has something. All of those have a way to get data in pretty efficiently. The thing I will say is remember that Hadoop is a very excellent distributed denial of service engine. If you have a 1,000-node cluster and tell it to just start slamming into a database, just make sure that your database is ready for that. And then I want to talk a little bit about consuming results. This is kind of that last mile. I'm going to show Data Explorer. We've got connectivity by way of ODBC and JDBC. So if you've got tools that speak ODBC, there are a lot of those. You can hook that up and use that. There are REST APIs to get to the data. You can also go direct to Blob Store, again, using the SDK. And again, that other model, which is, hey, I'm just staging some interesting set of data out that folks are going to work on down the line. And that would be another Hadoop job. So let's look at this real quick. So I've gone through, we've computed the similarities on all of these files. And I'm going to use a tool called Data Explorer. So this is an add-in to Excel that gives you a pretty nice query building experience. And let me walk through what I did. I won't build this in real time, but this is all pretty easy to do. I'm going to start with the source. This is just looking at what are all of the, let's zoom in here, what are all the files that are sitting in BlobStore. I'm going to filter that down. Hey, I only care about all of these files. All of there's 50 some odd individual part files. The reason there's those different part files is that that's just the way there is a part file for every reducer that runs, because that's the most efficient way to do it. If you have to combine them all, you can, but by default, it's just going to write a whole bunch of them. And so what I need to do now is, hey, I want to combine all of these. Let me pop out. Data Explorer has a really nice way if you want to combine all of these sources. Click this little button here. I didn't know that, and I was confused until I learned that. I'm going to import that as text. I'm going to split it into tab delimited files. I'm going to rename the column so that it makes a little more sense. I'm going to do a little bit of data type manipulation. And then I'm going to actually do a little bit more filtering based on, I want to make sure that I'm grabbing items that have been rated, that the intersection of the ratings is greater than 50. I want to make sure that I'm only looking at kind of the common sets of data. I'm going to close this. And now what we're looking at is all of that data that I've run over these millions of recommendations. And so what we'll do here is I'm going to pick a book, Fellowship of the Ring. I'm going to walk up and I'm going to sort it from largest to smallest here. And hey, this actually makes a little bit of sense. Folks who read one of the books have read the other books. Hey, our recommendation engine is actually kind of computing some interesting data. This is what I could go take into my system that's going to turn around and say when somebody browses to the Fellowship of the Ring, hey, would you like to go buy these other two? And there's kind of that's kind of the start of that pipeline. I can also consume from ODBC here, and that's just using the data source. So as long as there's an ODBC client, as long as you've got that installed, you can just program against the ODBC data source, issue your select query, and then go. The only thing I will say here is, again, remember your physics. If you're trying to bring down 1.5 terabytes of data into Excel, I'd encourage you to think about what you're trying to do there. ODBC across a single connection, that's a very thin straw when you're talking that much data. Where ODBC is super useful is, as I've processed down to a reasonable size of data, let me go ahead, pull that data into the system. The other thing that we've got, I've completely forgot to show this, my apologies. We've got implementations in .NET for doing MapReduce as well as Hive. And these are all NuGet packages that are available. So it's Microsoft.Hadoop, .MapReduce, .Hive, and .Web Client for either authoring jobs or integrating with a Hadoop cluster. And I just want to show one thing here, which is the link to Hive stuff that we've done. This will allow you to do two interesting things. One is it will let you write a link query, which will compile to Hive and then execute. And then somebody on our team has done something pretty interesting, and it has extended this. You see the flat map operation there. This allows you to define a .NET Lambda, which will get pushed down, pushed to all the nodes, and executed as part of your Hive statement. So this gives you kind of soup to nuts .NET authoring in Hive. So I'd encourage you to check that out. We'll switch back over here. So what do I do next? Next thing that I would do is, hey, I can schedule my execution. I can get more sophisticated analysis. Once I start doing more sophisticated analysis, I want to take that and I want to look at, was that actually useful analysis that I've done? And then I want to start to incorporate some more data sources. Little bit of quick check on where we're at from a status perspective. We're in preview right now. Everybody in this room with an Azure subscription can go out and sign up. We'll get you access in about a week. We're available currently in 2 Azure regions. That's just a point-in-time thing. We're in East US and North Europe. There's a discount on compute price right now, just as there was with the IaaS service. And all of the SDK and CLI tools that I showed are available. The links are at the end of the deck if you want to go download those. What's next? What's next for us is going to GA and being generally available. We just like websites and mobile services went GA the other day. That's where we're going. What that really means is we have the service to a point where we will stand behind it with an SLA that if we don't meet that SLA, we will pay you back. And so we've got a bunch of work. We've got work to do to get there. We'll be globally available across all of the data centers. There's a bunch of improvements that we're continuing to drive into Hadoop. The Stinger project is particularly interesting. We've been able to see up to 100x performance gains to certain query types to Hive. So there's some really nice work going on there that we're investing in contributing back to the Apache project to make Hadoop better. And then you'll see continued investments in cluster configuration, so I can pass settings files and jar files and a bunch of that stuff. Management with System Center and other tools, as well as improvements to the Azure portal. And then more integration and developer tooling. Set of resources, check these out. That's the end of the session. That's the end of build. I would like to thank everyone in this room for coming, particularly to the last session, because I know it's sunny outside. Really would appreciate feedback. Let me know what worked, what didn't work. I really appreciate it. Thank you, and go have fun and do some interesting computing with HDInsight. Thanks a lot. And of course, questions, feedback, personal attacks, all are welcome. That's the same set of bits. There's also a single node developer install,
right?
Which you can go to WebPI and just okay, I will use this one. Okay, so you can go to WebPI and you can download from WebPI. Just type in HDInsight or Hadoop, and in about 5 to 10 minutes, you'll get Hadoop up and running in a one-box developer playground kind of version. So check that out. The web platform installer. Yeah. Yes, that was a very good question. Thank you. Sorry, internal buzzwords coming out.
When you fire up the HDInsight, for nodes, are you able to configure the size of those nodes to keep the cost down? Because when you're first trying, you're not going to have large.
Question is, can we configure the size of the nodes? Not right now. We've got the right things in the configuration programming model to allow for that, but it's not a feature that we've got surfaced right now. You can imagine in the fullness of time, we certainly want to be able to give you the ability to config, because particularly there are certain, and to go the other way as well, if you want to take advantage of the high memory, the high-end VM sizes, you can do that as well, because there may be jobs that you're running that are very high mem intensive, and that's the type of analysis you want to do. Are we using HDFS internally? So internal to a HDInsight cluster, internal to Microsoft, internal to an HDInsight cluster? Yes. Although we specify that the default file system is the Azure Blob Storage one. So you can use HDFS. When your cluster goes away, that goes away. We prefer folks to go directly against Blob Store, because then it makes your cluster transient. And so, yeah, if you're a Hadoop guy, you look at that and you say, gosh, what about network locality? The talking point there is we've made a bunch of very deep investments into the Azure data center topology to put a very fast mesh network across the machines. And basically that kind of removes the economic constraint that most folks assume when they built MapReduce, trying to get compute close to data. Those are some pretty big pipes. And so we've actually seen cases where we can actually outperform local disk going against Blob Store. The pipes are that big. And again, any performance statement, your mileage may vary. Lots of asterisks. I'm sure there's, don't anybody write that down. But it changes the dynamic a bit. But it does give you that economic flexibility to say, cluster, go away. I'm still good. So, there you go. All right. Thank you very much, guys.